our aim. Good deal. So section 8.2, we're going to cover a couple different things. They're somewhat separate topics, but they're thrown into the same section. We're going to cover equations of lines, and we're also going to cover function notation. We're going to start with the latter of these two topics. So problems like number 50 give you something like this. In function notation, f of x is 3x minus 5. And basically what's going on here is that this f of x is taking the place of y. So up till now, you'd probably write this as y equals 3x minus 5. And one thing you could do would be plug in values for x, like a 3, and then figure out what the value for y is. Now, instead of writing all this, the convenient notation that we use allows us to do something like this. Find f of 3. So it says take that, plug it in here, and see what you get. So f of 3 is going to be 3 times 3 minus 5, or a total of 4. So 3 is your input, 4 is your output. So if you're keeping track of this on a t-table, f of 3 would equal 4. And then you could plot this and graph this function. Now the goal here, like I said, is to get used to the notation. So let's use the same function except a different value and take a look at f of negative 1. So f of negative 1, you're replacing this x by negative 1. So I'll do the same thing on the right-hand side of this expression. 3 times negative 1 is negative 3. Minus 5 is negative 8. So kind of extending that down, you'd have negative 1 and negative 8. Now you don't have to always stick with just f for the name of your function or x for your variable. Let's mix things up a little bit with problem number 52. G of x is x squared minus 2. And we'll do a couple problems and then even maybe a bonus problem. So for starters, let's try and find g of 3. And then g of negative 4. And finally, g of negative 6. Now the one thing that I would caution you about in using these formulas and making substitutions, and it's particularly true when you're working with negative numbers, is to substitute with parentheses. Now when I do these things, I'll always write parentheses and then substitute in. So for the first one, it's 3 squared minus 2, which is 7. Where it becomes a little bit more important, like I said, is when you have the negative numbers. When you plug in negative 4. When you square negative 4, what do you get? 16. But if you're actually being careful and you did something like this and you said, oh, well, negative 4 squared minus 2, really negative 4 squared written like this should give you a negative 16 because you're squaring the 4 and the negatives out in front. So if you wrote that, you should really end up with a negative 18. Just be careful with the parentheses and squaring those things out. How about the last one? What's the value there? Somebody gave it to me. Yeah, so negative 6 squared is 36. Minus 2 gives you 34. So what I'd be checking in something like this, if I gave you a problem, is are you squaring this out carefully? Are you getting 36 as opposed to negative 36? That's what I want to see you do. One last one like this, problem 64. H of x is x over x squared plus 2. And let's find a couple more values here. We'll start out with h of 5 and h of negative 2. So h of 5 and h of negative 2. This one, in addition to yet a different letter again, is a little bit different in as much as there's 2 places to plug in the value for x. So make sure you do both of them. Rachel, how'd the first one simplify for you? Perfect. So 5 over 27. And Demetrius, I don't think I picked on you yet today. How'd the second one simplify? Okay. Good. Now there's one more thing I'd expect. What would our final answer be? Perfect. Thank you. So negative 1/3. Please do put your problems in lowest terms. Is that okay? Is function notation pretty straightforward? Are you comfortable with this? Hopefully you saw this in your Math 1100 class. But it's not just in a math class that you'll see this. These kind of formulas are all over the place. So, no, I don't want that. There you go. When you talk about how long a pendulum takes to swing, so the time it takes a pendulum to swing depends on the length of the pendulum. And that's it. Just depends on the length. G is the constant of gravity. So you get T of L would be a nice way to express that formula. Wind chill depends on 2 things, right? Depends on the temperature and it depends on the speed of the wind or its velocity. So you see those 2 things here, V and T. Magnitude of the earthquake is really on a logarithmic scale. We'll learn about logarithms later in the course. So, as promised, your new home after you graduate, right? Yay! But can you afford the payments? Well, it's going to depend on a couple things. Your principal, rate of interest, and time. How long you're going to take out that loan. This one's kind of cool. Did anyone watch that series called Genius, I think it was? It was about Einstein. Yeah. All right. So one of the implications from Einstein's special theory of relativity is that if you're traveling really, really fast, it's going to look like your length shrinks in the direction of your motion. So this guy's going really, really fast relative to somebody who's standing still, and it's going to look like he's shrunk. And that shrinkage, called the Lorentz contraction, depends on your velocity. So kind of cool. The right size for letters on a road. They did an experiment, some psychological experiments to figure out what's the right size for road letters, and they came up with a formula. Of course, I think these guys need to go to school themselves. What do you think? All right, notice a little problem here? All right. But the right size for letters depends on the distance you're going to see those letters from and your height above the road. So the bottom line is that there's a lot of places you're going to see function notation. It's not just in a math class. So, all right, well, let's get back to things. We got a little bit more to cover in this section. We're going to move next to the equations of lines. So let's get back there. There we go. One of the most important forms of the equation of a line that you're going to work with is something that I hope you're familiar with, and that's the slope-intercept form of the equation of a line. So that's this one right here. Y equals mx plus b. M is your slope. B is your y-intercept. Let's see if we can't figure out the equation of this line. Now, when we calculate slope, if you actually have a couple points, you use this formula, y2 minus y1 over x2 minus x1. But there's another simpler way that your instructor may have introduced to you the idea of a slope, something over something else. Rise over the run. Good job. So the rise over the run. And let's see if we can't figure out the rise over the run and eventually figure out this equation for this line here. So as far as the run is concerned, how far is it that I move when I go from here to underneath this point? 4. Thank you. And how much of a rise do I experience going from here up to here? 2. All right. Well, that wasn't too bad. In fact,
that was easy.
Yes. So we got a slope of 2 over 4, or 1/2. Okay. So that's this term right here is the m. What's b for us in this case? -2. Wow, I think we got everything, right? This is going to be y equals 1/2 x minus 2. There's your equation. That's simple. Let's play around and practice with this stuff a little bit more. Let's see which one I want to do next. Sorry for the indecision. Here we go. Let's try problem number 96, which will be easy, and then problem number 98, which will be a little bit more challenging and interesting. So both of them are going to use this formula right here. This is called the point slope form of the equation of a line. This is supposed to be review, but if it's not review, you can look back in section 3.6 and get a lot more practice with this in section 3.6. Likewise, you can get more practice with this in section 3.5. So section 3.5. So if you need some extra help on those, that's where you're going to get it. Problem number 96 asks you to find the equation of a line with a slope of 2 passing through the point 0 and 11. Okay. Typically, when you do these problems, you're going to think of the point slope form of the equation of a line, which is this one right here. Y minus y1 equals m times x minus x1. If you want something that you need to remember for the final exam, that would be one of them. That will be on the final exam, or knowing this formula will be on the final exam. But we're kind of given everything we need. We've got the slope, and this is your x1, and that's your y1. So if I fill this in, it's going to be y minus 11 equals 2 times x minus 0. Generally speaking, I'm going to ask that you solve for y in these equations. So on the right-hand side, I'll distribute the 2. Since 2 times 0 is 0, I'll just leave that off. And last but not least, I'll add 11 to both sides and get this in slope-intercept form. 2x plus 11. Yay. Now, could we have done this better, easier, faster? Yes, for this particular one. Had you realized that the point that I gave you was actually your y-intercept. If you realize, oh, gee, that's the point 0, 11, I have a line that goes through there, yeah, you could have done it easier. You could have said, all right, y equals 2x plus 11. Generally speaking, you're not going to get quite so lucky to get the y-intercept as one of your points. So we're going to practice number 98 because it's not quite as simple. Are you okay with the first one, though? All right, that's a resounding yes. Thank you. Make me look good. All right, let's try problem number 98, where our slope is, where is it, 1/4, I think? Something like that. Yeah, slope is 1/4, and our point is 8, comma 1. Now we're going to do the same thing here that we did with the last one. We're going to use this formula y minus y1 equals m times x minus x1. So here's my x1 and y1 right there. See if you can't fill that in and make a little progress. Now, unlike our work in section 8.1, we do not recommend that you multiply everything by 4 and get rid of the fractions. Just distribute. See if you can't clean things up a little bit. It actually does work out pretty nice. Okay, so to fill this in, what's it going to look like? Nathan? Y minus what?
Y minus 1
Mm-hmm.
equals 1/4 and x minus 8.
Good. Thank you. Now what you can notice is that distributing on the right-hand side is really not all that bad. Because here I just get 1/4 times x. What's 1/4 of 8? 2. Well, that's nice. And if you add 1 to both sides, you end up with y equals 1/4 x minus 1. Yay. So that's your equation. Yeah. Let's take a look at that, graphically speaking. So I can go over to my friend Desmos here. I'll plug in our point. So let's see, zoom out a little bit so we can see our point. And now let's take a look at the graph. 1/4 x, or 0.25x minus 1. Yeah, and it goes nice and neatly through that point. You can double check that it satisfies everything. Not only does it go through that point, but if you take a look at the slope of the line, move over to the right, 8, so it's a run of 8 and a rise of 4. 4/8 is 1/2. Oh, no, wait, that's not 8, that's 2, because it's a different scale. So 2/8 is 1/4. Perfect. How are we looking on number 98? Yes?
For the point slope equation, could you, instead of doing that, can you just solve for b?
Solve for b? Yeah, there's nothing wrong with that. Nothing wrong with solving for b. I'm just not in the habit of teaching that way, but yeah, there's nothing wrong with solving for b. So what Nolan's suggesting is that you have this equation y equals mx plus b. We already know what the slope is, it's 1/4. So you can actually plug in some values and then solve for b. Nothing wrong with that. I just don't teach it that way, but there's nothing wrong with it. Okay, let's continue. Let's move on to finding an equation of a line between these 2 points. We'll talk about the application in a little bit. But if you have the points 6 and 14, and then 10 and 22, what if I ask you to find the equation of a line between these two? Now, this is not a problem from the book. It's an applied problem that occurred because I was playing a game of Words with Friends with somebody who was really smart. I used to call him Darth Worder because he was just freakishly smart and comes up with all these great words. But let's find the equation of a line between these 2 points. How would you do it?
y2 minus
Good. If you wanted to use the same formula we've been using, the one thing we need that we don't have is we need the slope. We need the slope of that line. So the slope is y2 minus y1 over x2 minus x1. In this case, 22 minus 14 over 10 minus 6. So 8 over 4, which is a slope of 2. Now I'm free to use either one of these points that I want. Now I know that as I used this slope formula, I regarded this as x1, y1, and this is x2, y2, but I really could pick either point. I'd suggest you pick the point that looks easiest and most comfortable to use. So y minus y1 equals m times x minus x1. Let's pick this point. So that's y minus, y minus 14 equals 2 times x minus 6. Y minus 14 equals 2x minus 12. If I add 14 to both sides, I end up with the equation y equals 2x plus 2. Yay. Does anyone play Words with Friends? Or used to? Used to? Okay. Yeah. I know your dad's pretty good at it. Yeah. He's Darth Vader. Yeah. Yeah. That's his dad. So, you know, his dad used to beat me pretty good in Words with Friends. And then one day he made this off-the-cuff remark. He's like, well, you'd probably do better if it involved math. I started thinking, I'm like, hey, that's an idea. And I started actually using math to help at least be competitive with him in Words with Friends. Now, in Words with Friends, they give you a word strength meter. So it gives you so many bars depending on how good your words score. So if I got 6 bars, that was worth 14 points. 10 bars was worth 22 points. So it's like, okay, well, if there's 17 bars, what's that last word I can get? How many points is it going to be if I spend a gazillion hours of my time trying to find that high point word? Anyways, I used to do statistics and linear problems to solve and try and be competitive with them. But you can make predictions and come up with the equation of lines for a lot of different things. It's not just frivolous stuff like this. If you find the equation of a line between these 2 points, 0 and 32 and 100 and 212, you'll end up with something that might be a little bit familiar. Do these numbers look familiar at all if you start thinking about temperature? Where are they from? Freezing point and boiling point in Celsius and Fahrenheit. And if you find the equation of line between these two, what you'll end up with is a formula to convert from Celsius to Fahrenheit. It's exactly where that formula comes from. And then you can make predictions too. Once you have a linear equation, you can make predictions. All right, our last equation, last problem here is going to be problem number 102. And I think I put a little reminder up here for you in terms of dealing with lines and the equations of lines. Parallel lines have the same slope. They have to. If their slopes were different, they would cross each other. So parallel lines have to have the same slope. Perpendicular lines have slopes that are negative reciprocals. Let's keep that in mind as we do our last one. So we want to find the equation of a line that passes through the point 2 and 20 and is parallel to the graph g of x equals 8x plus 1. So it passes through the point 2 and 20, parallel to g of x equals 8x plus 1. So here's a drawing of our graph. Here's the point 2 and 20 on this scale. You might notice that there's a 2 down here at the bottom. There's two things that you're going to need to know to find the equation of a line. We need the point, y minus y1 equals m times x minus x1. Let's do it on this. So our points again would be 2 and 20, and g of x is 8x plus 1. But this is a nice problem, and the mathematics department in general kind of likes this problem as maybe a final exam problem, even though it's not really covered that extensively in this course. So kind of a heads up on that one. Here's your x1, y1. So y minus 20, x minus 2. But what am I going to put in for the slope of this line? 8. Remember, the slope of this line is 8, right? Because it's in slope-intercept form. Even though it's not y equals something, y equals 8x plus 1, this is equivalent to that. If I put in 8 for the slope, a line that's parallel, that's what I mean by this little symbol here, is also going to have the same slope. So y minus 20 equals 8x minus 16. If I add 20 to both sides, y equals 8x plus 4. Nice. Now, how can I prove to myself that I got it right? I could graph it, but that might be more work than I want. There's two things you would have to check. One, you have to check that it's parallel, and two, you have to check that it goes through this point. Can anyone tell me that these two lines are parallel with certainty? Why? Same slope, right? So the same slope, m1 equals m2. Check, we got that. Same slope, 8 and 8. Last thing I need to check is that this point, or this line goes through the point 2 and 20. How do I do that? Plug it in. 8 times 2 is 16, plus 4 is 20. It checks. Cool. All right, let me wrap things up so I can get you out of here. Give you some homework for section 8.2. Homework would be 19 through 33, 47 through 73, 95 through 105, and again, that's just the odds, and that's section 8.2.